So this is the second part to the alkene video, and I know in the last part I said I'm going to be showing 4 new reactions. I made a mistake. I'm actually going to be showing the three remaining important reactions for alkenes. And so the first reaction that I have here is the addition of BH3, and I know this looks like a mouthful here at the bottom, but BH3 with THF, H2O2, and H2O, and those are just the things that you have to have around for your BH3 reaction to work. The most important thing in here really is the BH3, and I know that saying the most important thing may upset some chemists because you can argue the other things are important, but when you see BH3, this is the type of reaction it's probably referring to when you're dealing with alkenes. And what happens is it actually adds your alcohol, or your OH, to the Markovnikov position, so the not as tertiated position. And in our example in the last video where we added a Br2 in water, for example, Br2 and H2O, we saw that the alcohol added in the more tertiated position. And so BH3, in the presence of THF, H2O2, and H2O, is a useful reagent to be able to add our alcohol in the less tertiated position, or in the Markovnikov position. And so if you ever see a scenario where you have to add the alcohol to the Markovnikov position, it's probably talking about a scenario of BH3, assuming your reagent is in alkene. So the next reaction we're going to talk about is a reaction that's known as osmolysis, and it uses OSO4, and that's in the presence of CH3, 2, so 2 of those, and S, sulfur. And once again, the important reagent here that you may see more commonly is OSO4. And what this does is this actually adds 2 alcohols to either end of the double bond. And you can see those 2 alcohols right over here. They were added. And what's really important about the osmolysis reaction is that it adds in the syn addition. So they add in the syn addition, and that's going to be useful later on in organic chemistry. And so remember that they added the syn, which is really just in the same plane. And so the final reaction we'll talk about for our last alkene reaction, the last reaction was not an osmolysis reaction. This reaction is an osmolysis reaction, or is called an osmolysis reaction. So the last reaction works the same way, but it's not called osmolysis. The O3 reaction is called osmolysis, and what that is O3 in the presence of H2O2, and this is a very important reaction because it actually can break a double bond, so it can break an alkene, and what it does is it breaks where the alkene is, and so kind of make a cut in your alkene like that, and it puts a double bonded oxygen, and so in this case we're making, we're going to have just a double bonded oxygen and the hydrogen coming off of it. It makes a double bonded oxygen coming off of either end of your broken alkene. And so what you do is, once again, you break your alkene and you add a double-ended oxygen. Now, if you were to have a longer carbon chain, or a carbon chain that's a little bit more intricate, and you have a carbon coming off of one end. So, for example, if we had something like this as our starting off product, then you may not have a hydrogen here, you would have another carbon coming off one of your final products here. And so the bottom line is you cut your double bond and you make a double bonded oxygen coming off of either end.